Something shifted in the last 12 months, and I don't think we talked about it enough. Humanoid robots stopped being clunky, jerky machines that we laugh at when they fall over. They started being things that make you uncomfortable in a completely different way. Not because they're bad, but because they're too good. Because you look at some of them and your brain goes quiet for a second, trying to figure out if it's looking at a person. I've been following this space closely, and even I had to pause a few times this year. Let me walk you through the robots that genuinely changed the game and why I think this moment in history is gonna feel a lot bigger in 10 years than it already does right now. So let's start with the one that broke the internet in early 2026, because honestly it deserves the title. In late January, a Shanghai startup called DroidUp unveiled a humanoid named Moya at Zhangyang Robotics Valley, and the reaction online was split right down the middle. Half the comments were amazed, the other half were deeply, viscerally unsettled. Here's why. Moya is 1.65 meters tall, weighs around 32 kilograms, and DroidUp calls it the world's first fully biomimetic embodied intelligent robot. That's a mouthful, but what it means is they built this thing to feel human, not just look human. Feel human. The skin is silicone over lightweight lattice muscle materials, and underneath there's an actual ribcage structure. They added a heating system that keeps body temperature between 32 and 36 degrees Celsius, so very near the human body temperature. When you touch it, it's warm. Behind the eyes, there are cameras tracking your face in real time, and the robot responds with what DroidUp calls micro expressions, 25 degrees of facial freedom. The kind of subtle things you don't consciously notice but your nervous system picks up on. Moya's walking gait hits 92% accuracy compared to human movement. Not 70%, not 80%, 92%. DroidUp is targeting healthcare, education, and commercial environments where how a robot makes you feel actually matters. The price tag is around $173,000 right now, with a planned launch in late 2026. Is that steep? Yes, but Moya isn't just a product demo, it's a statement about where this entire industry is heading. I think Moya is genuinely fascinating, and yes, it is a little eerie, but that discomfort is just our brain catching up with a reality that arrived much faster than expected. The uncanny valley used to be something robots couldn't cross, and Moya is standing right on the edge of it. If Moya made you question what's human, GrowHR will make you question what's even possible for a robot body. Researchers at the Southern University of Science and Technology in Shenzhen published this one in the journal Science Advances in January 2026, and the specs read like something made them up. GrowHR is a soft humanoid robot weighing 4.5 kilograms. That's lighter than most laptops, mine included. And because it's built using bone-inspired inflatable linkage structures rather than rigid metal frames, it can extend its height by 278%, shrink its width by 61%, and squeeze through gaps that a normal robot couldn't dream of fitting through. The linkage can stretch up to 315% of their original length, and in crawling mode, it moves over 1,000 times faster than using motors alone. But here's the part that I genuinely like and that blew me away. Because it's so light, it can float on water, swim, and walk on water. Add a set of small ducted fans and it can fly. That single thing makes this robot operate on land, in water, in the air, and underground. Just because it's lightweight, it can move through all four environments, and because the body is soft and elastic, if it bumps into you, it doesn't hurt. The researchers explicitly noted it's safe to hug. Right now, GrowHR is a lab prototype, and it looks kinda funny, but the applications for search and rescue in disaster zones are genuinely compelling, and design doesn't make a difference there. A machine that can fly in, shrink to crawl through rubble, swim through flood water, and interact safely with survivors. That's an engineering roadmap and not a fantasy. Now, not every story this year was about jaw-dropping spectacle. Some were about robots quietly getting practical, and Limax Dynamics Ollie is a good example of that. Launched in summer 2025, Ollie is a full-size humanoid standing at 1.65 meters tall, weighing 55 kilograms with 31 degrees of freedom. The base model starts at around $21,800, and for a full-scale capable humanoid, that price is remarkable. Really. Unitree's H1 costs around $90,000. Ollie undercuts it by more than 75%. Now, what makes Ollie interesting isn't just the price. It supports over-the-air updates, runs large language models on board, and responds to natural language. In January 2026, Limax launched COSA, a dedicated operating system that fuses high-level reasoning with real-time physical movement. In a demo, Ollie was mid-task delivering water when it received a new instruction. It paused, processed the update, and adapted on the fly without being reprogrammed. The company raised over $200 million in early-stage funding and by February 2026, backed by Alibaba, JD.com, and Lenovo. Limax was founded by a former Ohio State University professor who believes the next wave of robotic intelligence doesn't have to originate in Silicon Valley. Watching Ollie learn kung fu moves with a human trainer and then dance in front of a live crowd at the World Robotics Conference in 2025, I'd say he has a point. Now, while everyone was watching China, Boston Dynamics made the biggest institutional move of this year. At CES in January 2026, the company unveiled the production-ready version of Atlas alongside a partnership with Google DeepMind, integrating Gemini Robotics foundation models into the robot's control stack. The numbers are serious. Atlas can lift 110 pounds, reach up to 7.5 feet, and operate in temperatures from -4 to 104 degrees Fahrenheit. Every 2026 unit is already committed, split between Hyundai's manufacturing operations and Google DeepMind. Hyundai is building a factory capable of producing 30,000 robots per year. What Boston Dynamics has done methodically over the past decade, through the hydraulic robot era, through the backflip videos, through the dancing spot clips, is built towards this. A robot that doesn't just show off, but works reliably, continuously, in an enterprise context where downtime costs real money. Atlas is being trained with large behavioral models through a collaboration with Toyota Research Institute, which means it's learning to chain complex sequences of locomotion and manipulation without engineering hand-coding every transition. Atlas going into Hyundai plants this year is a landmark, not just for Boston Dynamics, but for the whole conversation about what industrial automation looks like going forward. Here's a detail I keep coming back to because it tells you everything about where robotic dexterity is headed. On December 22nd, 2025, Tars Robotics held a live demonstration in Shanghai. Their humanoid robot threaded a needle and stitched an embroidered logo using both hands. That doesn't sound like much until you understand what it involves. Threading a needle requires sub-millimeter precision. Stitching requires adaptive force control across a flexible, unpredictable material that moves differently every time. Have you ever tried threading? I mean, I did, and I was terrible at it, and this is why this is so interesting to me. The robot had to coordinate both hands simultaneously on a task with no fixed positions and no scripted path. Tars calls this task long deemed impossible to automate, and they're not wrong. Their CEO described it as crossing a barrier that had blocked industrial robotics for years. Tars was founded on February 5th, 2025, so they did this within their first year of existence. They raised $120 million in an angel round and another $122 million shortly after. Their system runs on what they call a data AI physics approach, real-world data plus AI modeling plus hardware designed to close the gap between simulation and reality. The application that excites me the most isn't even embroidery, it's wire harness assembly, one of the most fiddly, precision-intensive tasks in electronics and automotive manufacturing that robots have never been able to handle at scale. If Tars can thread a needle, wire harnesses are next. Now, this one is harder to talk about with pure optimism, but ignoring it would be dishonest. In November 2025, during the 12th International Army Cadets Week, China's PLA demonstrated a motion-controlled humanoid robot to cadets and defensive representatives from 13 countries. The operator wore a motion-sensing suit, and the robot mirrored every punch, every defensive stance in near real time. Observers immediately compared it to robots from the film Real Steel. That demonstration fits into a broader doctrine emerging from Chinese military strategists around intelligence warfare. And then there are robotic wolf packs, autonomous quadruped units assigned specialized combat roles. Shadow units handle reconnaissance. Bloodstained units are the offensive corps equipped with micro-missiles and grenade launchers for direct assault. Polar units manage logistics and communications, acting as the command backbone for the pack. Operators guide these units through voice commands and gesture-based data gloves. The military applications of everything covered in this video are real, and they're being developed explicitly. I'm not being alarmist because I also think the civilian approach are genuinely life-changing, but the same advances in mobility, dexterity, and autonomy that let a robot thread a needle or help an elderly patient are the same ones making combat platforms more capable. That dual-use reality is something the world hasn't fully grappled with yet. And then there's this. Unitree Robotics, the company that shipped more humanoid robots than any other manufacturer on the planet, including Tesla, with over 5,500 units delivered in 2025 alone, just unveiled the GDO-1. The GDO-1 is a 2.8-meter manned mecha. A human pilot climbs into an open cockpit embedded in the robot's torso. It weighs roughly 500 kilograms with a pilot on board, and it walks on two legs, punches through brick walls within the demo video, and then folds its chassis into four-legged crawling configuration in seconds. The founder of Unitree, Wang Xingxing, climbed in himself and drove it down to a city street in the promotional footage. The price is 3.9 million yuan, which is roughly $650,000, and Unitree calls it the world's first production-ready manned mecha and positions it to be a civilian vehicle for rough terrain transport, exploration, and rescue. They also filed for a $7 billion IPO on Shanghai's Star Market this year. A 650,000 transforming robot is not going into most people's garages anytime soon, but the fact that it exists as a purchasable product and not a movie prop tells you something important about the pace of this industry. Things that were science fiction 5 years ago are now spec sheets with a price attached. Now, I want to be clear, I like where this is going. A robot that feels warm when you hold its hand could mean real companionship for isolated elderly people. A robot that can thread a needle could unlock manufacturing jobs in places that can't compete on labor costs. A robot that crawls through rubble could find survivors who would otherwise be unreachable. The humanoid form factor was always the goal because human environments were designed for human bodies. Every door handle, every staircase, every tool grip was sized for us. Robots that match our form can operate in our world without rebuilding everything around them. That insight has been driving all of things, and in the last 12 months, the gap between theory and reality closed faster than anyone expected. This was the year humanoid stopped being a promise and started being a presence, and I think we're going to look back at this period as the moment that the line blurred, maybe for good.